Let's talk about the Giga press. The Giga press is the largest die casting machine in the world. It can weigh up to 430 tons and have a clamping force of up to 61,000 kilonewton. Additionally, these gigantic die casting machines are as big as a house and capable of casting extremely large components. Tesla is the first company ever to order the Giga press, and here's why that's so important. The name Giga press was first introduced by Riccardo Ferrario, the general manager of Hydra. The Hydra Group introduced the Giga press in 2018. It has been in their catalog since then. It was only until 2020 that Tesla had started using a customized Giga press for production. Elon Musk mentioned that Tesla had bought two huge die casting machines to manufacture chassis parts for the Tesla Model Y, and also the rear chassis of the Tesla Cybertruck using a Giga press with over 8,000-ton clamping force. The Giga press is more like a die casting setup than a machine. It is equipped with all sorts of devices and systems required in a die casting process. The components in Tesla's Giga press include: the Giga press uses two sets of ovens for handling the aluminum alloy. One functions as a melting oven powered by natural gas and operates at 850 degrees Celsius temperature. Another oven stores the liquid metal heated by electrical power and operates at 750 to 850 degrees Celsius temperature. It is the core of the whole setup, or the die casting mechanism. It has a similar construction to any regular high-pressure die casting equipment and functions like one, except that it is enormous in size. The Giga press uses a 4,000-liter tank for creating a vacuum inside the mold. The quenching tank rapidly decreases the temperature of casting to a desirable limit. It is allowing one to achieve some specific properties for a metal casting. There are mechanical trimming press and laser trim for rapidly cutting of excess metal attached to the casting. There is a recycling system to utilize the scrap metals. The scrap aluminum is shredded, and offcuts are utilized for the next casting cycles. The working principle of the Giga press can be divided into the following steps: material preparation, die preparation, casting, finishing. First of all, we have to melt the aluminum ingots and cutoffs from the previous casting cycle in an oven at 850 degrees Celsius temperature. Then, remove any impurities from the surface and convey the liquid metal into another enclosed oven using heated pipes. That oven maintains about 750 to 850 degrees Celsius temperature. Fill empty space inside the storage oven with nitrogen gas prevents the formation of oxides in the molten aluminum. It also helps to maintain an even temperature. Additionally, operators use argon gas, rotary degasser, and a silicon carbide filter to further remove impurities. Before commencing each cycle, lubricate the die surfaces. A robot sprays about 35 milliliters of soybean oil in a thin layer to enable easier separation of the casting. Then, the vacuum system creates about 50 millibars of vacuum pressure inside the mold cavity. The molten aluminum is transported from the holding oven to the shot chamber of the Giga press. There, the molten metal is forced inside the cavity using a high-speed plunger. The plunger is also lubricated using 8 milliliters of oil before each shot. Once injected, the casting is left inside until it solidifies. Then, the casting is ejected from the dies at 400 degrees Celsius. The raw casting is then placed in a quenching tank to reduce the temperature from 400 to 50 degrees Celsius rapidly. It helps tackle some defects and increase some material properties. Cool the open die to 185 degrees Celsius and thoroughly clean it with robots to prepare it for the next cycle. The next casting cycle will begin 1 to 2 minutes after the current one finishes. Now, cut each of the raw castings into approximate dimensions using a mechanical trim press. The scrap aluminum is recycled with a scrap metal shredder and added back to the oven. Then, the main casting is checked with an X-ray to examine whether it has any internal defects. The verified casting is further perfected using a laser trim and drill using a CNC machine for fittings. Finally, check the finished casting's accuracy with a coordinate measuring machine. Currently, the only sites to have installed or planning to install the Giga press are the Tesla factory located at Fremont and 3 Giga factory located in Shanghai, Berlin, and Texas. We are hoping for new possibilities with the Giga press technology taking shape. While still not fully implemented, We can already perceive the potential this technology can offer. The Giga press will greatly improve the production efficiency of large and complex products. The Giga press will allow manufacturers to cast large a single component as opposed to numerous smaller parts. Therefore, it will virtually eliminate the assembly operations involved. Thus, there will be great savings in time, labor, and eventually the cost of production. Casting a larger single piece will allow the manufacturer to produce a lightweight structure and impart additional strength to the casting. Casting a single component would also eliminate the possibility of having alignment issues of parts while assembling. So, it will simplify quality control and allow manufacturers to provide high-quality castings. Moreover, it will minimize the need for robots in production and significantly reduce the body shop size. So, there will be savings in land use as well. Currently, the major field of application of the Giga press seems to be automotive castings. Automobiles have complex structures and built using numerous smaller parts. Trimming down the number to a few castings would surprisingly boost production efficiency. Tesla is working on casting the rear body structure of the Model I using the Giga press. It will replace 70 pieces of castings into a single piece. They are planning to cast the front chassis component using the Giga press as well. It definitely changes our view on the current production techniques. Since this is a relatively new technology, it may take some time before seeing more applications of this technology. We are optimistic to see more innovative use of the Giga press in other industries as well. So why would anyone want to go to the effort of using a massive superpowered casting machine to manufacture their vehicle frame? There are several reasons, but they can all be summed up in one word: efficiency. This new casting approach from Tesla is going to be critical for the future of the company and especially new vehicle programs like the Cybertruck. Tesla was always having this problem of meeting deadlines when it comes to deliveries, and Elon Musk, in turn, keeps on mentioning at every new product launch or update that he's trying to ramp up things in every way possible, but that's still something they should focus on even now. So this Giga press is something that Tesla needs to fasten up production speed so that the company can at least reduce the problem of meeting deadlines by at least 5%. This will help the company to perform better and increase the production speed in a big way, because every new positive involvement helps a company get more shareholders, which eventually gets them more money and ability to do things they want to. What all of this translates to is an improved speed when it comes to production, at least to one aspect, because Tesla's ultimate aim is to ramp up the production speed so much that they shouldn't bother about meeting deadlines, and this Giga press makes the process a little faster compared to the regular one. To get a better understanding of how this casting technology works, Tesla has released an impressive new video of one of those giant cast parts coming out of the Giga press. You can see the single part, which is basically 1/4 of an entire car body, still smoking after coming out of the press. Now Tesla is going all in on the giant casting technology. The concept of mega casting is sure interesting, but the sustainability of the technique is still questionable to many. Since this is a new technology, there is still a lot of research people need to do on the Giga press's efficiency, cost, stability, and reliability. The industry has always been skeptical when it comes to embracing a new concept, so it might take some time for other manufacturers to follow the mega casting trend. So far, the information we could get from Tesla is limited. Tesla has been successfully producing trial runs of the Model I rear chassis, although it is certain that it required them numerous iterations to get there. But the design process for mega casting should become easier as manufacturers gain more insight into the technology. However, we need to be extra careful when handling such a large quantity of aluminum at once. Recently, a Giga press at Tesla's Fremont factory caught fire during production. The Fremont Fire Department stated that the cause of the fire was molten aluminum and hydraulic fluid. But it was nothing serious, and nobody would get hurt. As you can see, there are some potential risks to consider with mega casting. However, we believe that we will overcome as the technology develops further.